right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, unpause the video, and I'll show you the correct answers. So this factoring is going to be x squared plus 4 times x squared minus 3. And so that'll be your answer for that. For the math knowledge question, we are looking at the graph of a line. When we buy 0 hamburgers, our cost is $0. When we buy 1 hamburger, the cost is 99 cents. 2 hamburgers is $1.98, and then 3 hamburgers would be $2.97, and you could just keep going from there. Now, he gives the correct response that the slope between any 2 points on this graph is always the same positive number, because to figure out the cost of your purchase, you're just going to take the number of hamburgers times 99 cents. And so it's always going to be the same positive value. The slope on this is positive 99 cents, because that's how much it goes up every time you add a hamburger. All right, so we are looking at lesson 81. We're dealing with solids of revolutions, part 2, looking at washers. Now, back in lesson 71, we looked at solids of revolution, part 1, dealing with disks, and we had the formula integrate from a to b pi f of x squared dx. And so we're going to look at a very similar formula, but now we're going to be having washers instead of disks. So hopefully you'll understand solids of revolutions part 2 today. So some solids of revolution have cavities, and their volumes can be computed as the difference of 2 volumes. So if you've got a part that's missing, you're going to be computing it as the difference of the bigger volume minus the one that's pulled out. So that formula is going to be the integration from a to b of pi r squared minus pi r squared. Now you're going to have 2 different r's. One is going to be a big R and one is a little r. And now this one says dy because our figure is going to be rotated about the y-axis if you look here. So we're going about the y-axis. To figure out which one is your big R, you're going to look at your y-axis, your axis of revolution, and then the function that is further away from the axis of symmetry is our f of x function. So on this one, our f of x is going to be our big R. And then our little r is going to be the function that is closer to the y-axis. So if you look, this function is closer to the y-axis, and so that's going to be your little r. And if we rotate it, we would get a figure that looks something like that. Basically, you're going to find the volume of the whole thing, and then you're going to subtract the volume of the part that is taken out. This kind of looks like a cup or a vase of some sort. You would find the volume that the whole vase would be, and then you would find the volume of the inside and subtract them to find out what your volume of your vase or your cup is. And they call it a washer because if you cut a little piece of it, it would basically make a washer. And so that would be the representative washer for these problems. Now, if you want to do with respect to x, and you rotate a figure, it may look like that. But it's going to be about the x-axis, and so that's why you would do dx. So let's look at an example. We want to find the volume of the solid form by revolving the region that they show us about the y-axis. So we're going to start with our function. Volume is, we're going about the y-axis, so we're going from 0 up to a 4. And then we're going to have pi something squared minus pi something squared dy because we're going about the y-axis. Now, our function that is our big R is going to be our f of x. So y equals x squared, but we have to solve that for x because we need it in terms of y. So take the square root, and so x equals the square root of y. So I can plug that in here, the square root of y. And then for my little r, that is going to be the function for g of x because it's closer to the axis of symmetry. And so y equals 2x squared. So 1/2 y equals x squared, and then take the square root. And so x would equal the square root of y over the square root of 2, which is going to be the square root of 2y over 2 if you want to rationalize it. The square root of 2y over 2. Now you don't necessarily have to do that because when you square it, it is going to simplify. But if you want to, you can. And so now we're going to simplify it just a little bit. We're integrating from 0 to 4 pi of y, because the square root of y squared is just y. And then we have minus pi, and the square root of 2y squared is going to be just 2y, and then 2 squared is 4. So 2y over 2 is just y over 2, and then with respect to y. Now we can go ahead and combine those two terms. Y minus y over 2 is just 1/2 y. So now we can integrate that, pretty straightforward. We're going to have 1/4 pi y squared from 4 to 0. And then you plug in your 4, and then you plug in your 0. That term's going to disappear, and 1/4 of 4 squared is just 4, and then we have pi. And our units are going to be cubed because we have volume. And so that would be the volume for that figure there. All right, so let's look at the next example. We want to find the volume of the solid form by revolving about the y-axis, the region bounded by y equals x equals 4, and the x-axis. So we're going to integrate for our volume. We are going about the y-axis. We're going from 0 up to 4. So from 0 up to 4. And then we're going to have pi, big R squared minus pi, little r squared, and then dy. Now, our big R is going to be from our axis of symmetry all the way to here, which is just a 4. You can't really put that in terms of y, so it's just a 4. And then our little radius is going to be from the axis of symmetry to the line y equals x. All in terms of y, that just equals y. So now we can go ahead and square those two pieces. And so I have 16 and then y squared. And now if I integrate that, I'll have 16 pi times y minus 1/3 pi y cubed from 4 to 0. So now you're going to plug in your 4 and your 0. And then if I plug in 0, I'll have 16 pi times 0 minus 1/3 pi times 0 cubed, which all of that actually goes away. It just equals 0. So now 16 times 4 is 64 pi. And then 4 cubed, 64 over 3 pi. And so if you simplify that, you're just going to get 128 over 3 pi, and then again units cubed because we have volume. And so that would be the area of the figure that is rotated about the y-axis. Looking at the next example, we want to find the volume of the solid formed by rotating this graph about the x-axis. So we're going to start with our formula. The volume equals, we are going from 0 to 1. And we have big R squared, little r squared, and then dx, because it's going about the x-axis. So looking at our graph, the one that is further from the axis of symmetry is this function, which is the square root of x. And that's already in terms of x, so we can just leave it as the square root of x. And then looking at the one that's closer is going to be the x squared. And again, that's already in terms of x, so we just go ahead and put in x squared. So now we're going to simplify before we integrate. And so I end up with pi x minus pi x to the fourth. If I integrate, I'm going to have 1/2 pi x squared minus 1/5 pi x to the fifth from 1 to 0. So 1/2 1 squared times pi minus 1/5 times pi 1 to the fifth. And then minus, if you plug in a 0, you will get 0. So I have 1/2 pi minus 1/5 pi, which is going to give you 3/10 pi. And then you have units cubed. And so that would be the volume for that figure. Okay, looking at the next example, we have the region between the graphs of x squared plus 2 and 1/2 x plus 1 on the interval 0 to 1. And we're going about the x-axis, and it wants us to find the volume. So our volume, we're integrating from 0 to 1, because they told us that's the interval. And then we have pi, radius squared, minus pi, radius squared, and then dx. Now, if you look, the one that is further away from the axis of symmetry is your parabola, which is going to be x squared plus 2. And then the next one that is closer is going to be the 1/2 x plus 1. So what we need to do now is actually distribute those, and hopefully we'll have some terms that will combine. Now, I haven't shown you before, some of you may have already been doing this, but you can actually factor out a pi from both terms, because they both have a pi. So if you would like to do that, or if you've already been doing that, that is perfectly fine to do. So x squared plus 2, if you square that, it's going to be x to the fourth plus 4x squared plus 4. And then if you square this one, you're going to have 1/4 x squared plus x plus 1. And then with respect to x, we can combine a couple of the terms, so we'll go ahead and combine those. And we'll have x to the fourth, and then plus 15 over 4x squared, and then plus x, and then plus 3. So now we can integrate that. So I have 1/5 x to the fifth plus 5 over 4 x to the third. This is actually a minus x here. So minus 1/2 x squared, and then plus 3x. And we're going from 1 to 0. So now we plug in. You plug in a 1. You'll have that, and then when you plug in a 0, you'll get a 0. And so now we're just going to simplify. So I have pi 1/5 plus 5 over 4 minus 1/2 and plus 3. And if you add those all together, you're going to get 79 over 20 pi, and you'll have units cubed. And so that would be the volume of that figure if you rotated about the x-axis. So that's how you deal with the solids of revolutions when you're dealing with washers and you've got two separate functions. You just start with the one that's further from your axis of symmetry and then subtract and do the one that is closer to the axis of symmetry. So hopefully that helps you with that lesson. Your homework, you do not have any to omit, So you need to make sure that you do all of those tonight, and then we'll go over any questions that you have tomorrow.